Hi, this is worked example 19 from exercise 7.07, modifying loans. So Zoe is borrowing $80,000 at 7.5% compounding monthly over 9 years with monthly repayments of $1,020. After 4 years, the interest rate is reduced to 6% per annum. What is the new repayment amount required for Zoe to pay off the loan in the same amount of time? And how much does Zoe actually save with the reduction in interest rates? So Zoe, I'm not sure what you're buying, but it's very exciting. So let's work it out. This A, to find out the new repayment, we have to first find out the balance after 4 years. So we're going to go to find the balance after 4 years. Okay, so we need to use this equation. The BN equals A, the amount, R to the N minus Q, R to the N minus 1, all over R minus 1. Now, just before I ran out of room, so I'm going to stick this over the side. So N is the first variable there I need. The amount we want to know is after 4 years. So 4, and it's being compounded monthly. So it's 4 times 12, and that gives me 48. The A is the amount, and we are borrowing, well, actually Zoe is borrowing 80,000. The R is equal to 1 plus the interest rate, which is 7.5 over 100, so it's a decimal, and then we have to divide that down by the number of repayments, and that's trying to be a 12. So this gives me 0.00625. Q is the only remaining variable there that we need, and it's the repayments, and it's 1,020. So if I come back and start a little bit further over here so I don't run out of room this time, B is the balance after 48 repayments is 80,000 times R, 1.00625 to the power of 48 minus the repayment R, 1.00625 to the 48. Oh, I'm still nearly going to run out. Minus 1 all over R minus 1. And I would do this as two sums so that it's simpler on your calculator. And this first section becomes 107,887.93 minus $56,891.38. So it gives us a total balance, or balance after 4 years, of $50,996.55. All right, so that's the first part, because now I need to know what the new repayment was. So I found the balance in 4 years' time. So what's the new repayment? And that's that other equation, the Q equation. So now use the balance at 4 years of 5996.55 to determine the new repayment. Oops. So that's the Q formula. So the Q formula from the previous chapter is Q is equal to A R to the N multiplied by R minus 1 over R to the N minus 1. So we need similar ones. Our A now is equal to $50,996.55. Our R, okay, so there was 9 years in total, and I've used 4, so I've got 5 years remaining, and I'm still paying it monthly. So I have 60 repayments left. That's the N, not the R, just excuse me. The N is equal to 5 years remaining times the 12 monthly repayments, gives me 60. The R is equal to, where am I? 1 plus the new repayment, 6%, and that gives me 1.005 on the calculator. And so I'm going to put all of this into the equation now. Have I got everything I need? A, N, and R, yep. And I'm going to solve for the Q, the new repayment. So $50,996.55 times the R, which is 1.005 to the 60th. All right, looking like I might run out of space here. So R, 1.005 minus 1, all over 1.005 to the 60, power of 60 over 1. And if you put that into your calculator, because it's all multiply and divide, except for this this section down here where we've got to subtract, make sure you put that in brackets. You'll be able to calculate that in one foul swoop, and it should come out to $985.91. So that's her new repayment value at the end. Now, that's excellent, except that how much does she save? So, the B part is how much does she save? How much does Zoe save? Oops. So each payment, she was paying $1,020 and now she's paying $985.91. And whatever that amount is, she's going to save that amount in the next 60 payments. So she has 60 repayments left, and she's going to do that. So if you put that into your calculator, I've just come up with a wonderful figure that doesn't follow along here. I'm just going to double check. If you put that into your calculator, you come out with $2,045 in total savings over the next 5 years. So we would save $2,045 with that change in interest rate.